Hey guys, I'm Amit Kumar and welcome to this video in which we are going to talk about rules of conversion. Now conversion means converting one data type to another data type, and there are two types of conversions: implicit conversion and explicit conversion. When conversion takes place automatically without any programmer's intervention, then that conversion is implicit conversion. Explicit conversion is that conversion where the programmer explicitly specify the target data type for conversion. Now Apex supports implicit conversions with following types: numbers, string, and IDs. Number supports implicit conversion with a basic rule. That is, once a value has been passed from a lower type to a higher type, the value is converted to the higher type of number. And this happens implicitly. Now the following is the hierarchy of numbers from lowest to highest, where integer is of the lowest type and decimal is of the highest type. Hence, an integer can be implicitly converted to a long to a double, and a double to a decimal. Now for strings and IDs, IDs can always be assigned to strings, and that can be done implicitly without any issue. Strings can be assigned to IDs, however, at runtime the value is checked, and if it is not a valid ID, a runtime exception is thrown. Now the following points to be considered with the data types. By default, numbers are integers, so all the number literals are by default integers unless they are appended with an L for long, or a .0 or a dot or any other number over there for double or decimal. If the numeric value exceeds the range, then we get a compilation error, and it must be appended with any of the above. Arithmetic computations that produce values larger than the maximum value of current type are said to overflow and result in an incorrect value. For example, the calculation of milliseconds in a year, and when you are doing it with normal integer value and assigning it to a long type. Now we will see that in the practical session as well. When dividing numeric, integer, or long values, the fractional portion of the result, if any of them is existing, is removed before performing any implicit conversion to a double or decimal, which results in a loss of fraction. So suppose you are doing some sort of division with integer values, then definitely when both the values are integer, the result will be an integer only. But if you are assigning it to a decimal or a double, assuming that the result will come into a double, then that's completely wrong. Though you will get the result into a double value or a decimal value, but you won't get those fractions that should be there. The reason for that is, if you are operating two integers, then those two integers will result into an integer and it will not have any fractional part. And when you will assign that integer to a decimal, then definitely you are going to do the implicit conversion and it will add just a .0 to it. So that's pretty much of talk, and now it's time to see the rules of conversions practically. So guys, here we are in our console, and let's create a program for our numeric conversion. So as you can see, this is very simple program where we have created an integer variable, assigned an integer value to it, then we assign that integer variable to a long variable, then that long to a double, and then that double to a decimal. So definitely these will do all the implicit conversions because it is according to the hierarchy of the data type, and when you will print the value, it will print them accordingly. So as you can see, integer values are integer and long are printed over there. You can see the double and decimal as well. So let's create a program for our string and ID conversion. So guys, you can see I have created a program where I have created string variable str1, and where I will assign an ID, and that I am assigning to an ID variable over here. The reverse also I am doing. I am creating an ID, assigning an ID to it, and then assigning that ID to a string. And we will print all these values. So you can see the implicit conversion will take place. And to show you that, let me copy an ID from our arc. Now when the string is assigned to ID and when this ID is assigned to string, these conversions will take place automatically, showing you the example of implicit conversion. So let's run and see the output. So guys, you can see how the string value and ID value have been printed comfortably without any error or without any issue. But I told you that if we are assigning a string to an ID and when the ID is not correct, definitely it might show some error. So let me add some code for that. So guys, you can see I have created a string variable over here, assigned an ID to it, and then assigned that string variable to an ID variable. Now intentionally I'm going to make this ID as wrong by removing some of the characters from the beginning. I'm removing 4 characters. I should say 5 characters from the beginning. Now this is a wrong ID. Let's save it and let's try to run it. And you can see it is showing a string exception and the exception is invalid ID. So if you are having an ID in form of a string and assigning it to an ID, definitely that has to be a correct ID. Otherwise it will show a runtime exception. So guys, let's create another program to see the considerations while doing the conversion. So here we are with our program. There are plenty of things that I have done here. Now in the first line, you can see I created a long variable and assigned a long value to it. Now this value is well into the range of a long, but still it is showing an error. And if I see the problem, it is showing illegal integer. The reason being, I told you all the numeric values are by default integer. So what the compiler is thinking that you are trying to specify an integer over here. But this value is quite beyond the range of integer. The maximum value an integer can hold is this one. That is 214,748,3647. And if I try to save it now, it will save successfully. Because what I'm doing is I'm assigning an integer to a long and implicit typecasting will take place. But when I will try to write this value, which is quite beyond the range of integer, the compiler will say this is not a valid integer value. And definitely the compiler is right because all the numerics are by default integer. So we have to tell that this is a long and not an integer. And how we can do that? By using or by appending an L with this number. So when we will do that, the compiler will understand that this is a long value and not an integer value, and definitely a long can be assigned over here. Now in the code in line number 6, what I am doing is I am using a normal integer value, adding it to a normal integer value. While this is within the range of integer, this is within the range of integer, but the sum of this expression is beyond the range of integer. And what happens actually in that case, the value overflows. The value go beyond the range. Actually it doesn't go beyond the range. It actually moves to the leftmost part of the range. So this is the range of an integer. The minimum value is this one, the maximum value is this one, and all the values within this range, including them, are valid integers. So if I'm going to add 1 to it, it can't go beyond this value. So what will happen? It will revolve around this range itself. So it will come to this value and it will show this value as the output, which is definitely wrong. And this is known as overflowed integer value. So to see that, definitely we have to run the program, but we will come to that after discussing the next case. Now suppose if we are calculating the number of milliseconds in an year, we do that by multiplying the number of days into the number of hours, into the number of minutes, into the number of seconds, into the number of milliseconds. It is 365 into 24 into 60 into 60 into 1000. And that will give us the number of milliseconds in an year. But this specific value is quite beyond the range of integer itself. So again, it will give us a wrong value. It will do something like this, revolving around the range, and definitely that will overflow. So to overcome this, the solution is to add this L. So what will happen? We are performing operation on long, and hence the multiplication of all these numbers will be within the range of long, and you will get a correct value over here. So let's see the output of this program. So guys, you can clearly see the first value is valid because it is within the range of a long. We have added that L, we have appended that L, and that was working. The second one is the case of overflowed integer value, and you can see it is showing that negative value which I was talking about. The third one is also a case of overflowed integer, and it is within the range of the integer, but the correct value is displayed in the last statement where we have used the long integer literals for the multiplication operation. I have told you one more thing about loss of fraction, and to show you that, let's create a decimal over here. I would expect a fractional part in this value. Definitely I will get the fractional part, but not the correct one. I will get the loss of fraction. So let's see that in the output. So you can clearly see 1 because the output it would be showing is 1.0 in the console because it was 0.0, hence it was not displayed. and that was the loss of fraction which I was talking about. So in case if I change this to 5.0, I would get that decimal value over here. Definitely this is not a precise decimal because this is a non-terminating repeating decimal example, but definitely if you are facing any such loss of fraction issue, that might be because you are operating on integer and you are expecting in decimal. The best way to deal it is convert one of the value or both of the value into decimal and then perform the division. Definitely you won't face any loss of fraction. So that was all about in this video. See you soon in the next video. Till then, thank you and take care.